Math 1343, confidence intervals. Confidence levels. On the board, you see a word problem that has already been answered, so to speak. There's one sentence, and normally there would be a question afterwards, and then the second sentence is the answer to that question. From a population of mosquitoes in East Texas, a sample of n equals 1,000 is studied. So they gathered up 1,000 mosquitoes, and 40 of them carried the West Nile virus. As a question, the next question part would be, calculate a 95% confidence interval for the proportion of all mosquitoes in East Texas that carry the West Nile virus. In other words, try to make an estimate about the population based on this sample of mosquitoes. But I've already got the answer, and later on we'll talk about how to get to this answer. We state with 95% confidence that the percent of all East Texas mosquitoes that carry the West Nile virus is from 2.78% to 5.22%. This is our interval estimate based on this sample. And by the way, what percent of our sample carried the West Nile virus? It's not important for this video, but it will be later. Well, out of the 1,000, it was 40. So if you divide 40 by 1,000, you get 0.00. Hold on. Yeah, if you divide 40 by 1,000, you get 0.04, which is 4%. It may not be obvious, but this interval is centered at 4%. You can figure that out by calculating how far apart both of these are from 4%, and you'll see that they're the same distance. But that's not the point of this video. The point of this video is to discuss what do I mean when I say 95% confidence. Now, some people incorrectly think that means that there is a 95% chance that the value of P, the percent of all East Texas mosquitoes that carry the West Nile virus, is in that interval. Well, that's not actually what it means. What it means to be a 95% confidence level is the following. When we build this confidence interval, and we will go through this exact example soon, we start by figuring out the percent that we got from our sample. And again, the percent from the sample, which would be P hat, is the 40 out of the 1,000, which is 0.04, which is 4%. So if we're going to make an interval, we have to center it at 4%. Now, I haven't told you how I've calculated it yet, but the margin of error for this particular scenario would be 1.22%. And when the time is right, we'll go through the details, which means that we would add 1.22% to get the right end of that interval, and we would subtract 1.22% to get the left end of that interval. So if you think about this as shading in part of the number line, but I'm actually going to shade it above it, that red bar kind of represents this interval, and it's centered at 4%. So we state with 95% confidence that the percent of all East Texas mosquitoes that carry the West Nile virus is somewhere between here and here. But what does that 95% actually mean? Well, here's what it means. If we gathered 1,000 mosquitoes and 40 of them carried the West Nile virus, this is what we would conclude. But let's say another group of entomologists, I think that's the correct word, I may be wrong, but let's say another group of people gathered a different sample of 1,000 insects, and in their sample, they didn't count 40 of them, they counted 50 of them. Well, if they counted 50 of them, then that would be 5% at the center of the interval. As we go through these videos, you'll see that the margin of error would actually remain the same. So if somebody else took a different sample and got 5% instead of 4% with the same margin of error, their interval would be here, but it would stretch out the same distance in both directions. But let's say a third person or a third group gathered a different group of 1,000 mosquitoes, and they came up with 3% of them had the West Nile virus. Well, under these same numbers, with the exception of this, we would get the same margin of error, and so their interval would be centered at 3%, which is about here, and it would stretch the same distance in both directions. So the location of your interval is 100% dependent on the point estimate you get from your sample. In this case, what percent of our sample carried the West Nile virus. But with the same sample size and with the same confidence level, we would get the same margin of error. And so it's almost like somebody's just taking these portions of the number line and moving them around. Now, here's what the 95% means. Imagine a population of a bunch of mosquitoes. Let's just say 1 million of them. There's a lot of ways you could pick 1,000 of them. I'm not going to get into the mathematics of it, but the number of ways you could pick 1,000 mosquitoes out of 1 million is so large, it would be impossible to do with the remaining time left for the planet Earth, I would bet. But let's say that we did. Let's say that you took every possible sample of size 1,000 and created its confidence interval, all of which would have the same margin of error. Then you would have, I don't even want to say trillions because that's not doing it justice. You would have so many of these little number lines all over the place, just sitting above here. Some of them would overlap, some of them wouldn't. Some might be over here, some might be way over there. Maybe somebody took a sample and 20% of them had West Nile virus, and it would be way over there off the board. So here's what the 95% means. If you created every possible confidence interval by taking every possible sample of that size from the population, 95% of them would have the true value of P in them. In other words, 95% of all these intervals scattered all over the place would contain the correct percentage of all mosquitoes that carried the West Nile virus. So that's what the confidence level means. Out of all the possible samples, 95% of them would create confidence intervals that contain the true value of P, the population proportion. The good news is you can actually calculate confidence intervals without knowing that, but I don't think I would be doing it justice if I didn't at least explain what that 95% meant. Now we'll use the 95% as you'll see shortly, but that's what a confidence level means. It means if we created every possible confidence interval from every possible sample, this percent of them would contain the true value of the population parameter. In this case, 95% of every possible intervals would contain the correct percentage of all the mosquitoes that have the West Nile virus.